Hi everyone, Chapter 4 Chemical Bonding 4.1 Lewis Structure Part 1. In this subtopic, you will learn how to write the Lewis dot symbol, and you should know the octet rule and describe how atoms obtain the octet configurations. Then you need to apply these two in the formations of the bonds by using the Lewis dot symbol. Formations of the ionic, also known as the electrovalent bond, covalent bond, dative, or also known as a coordinate bond. For draw Lewis structure, I will explain this in the next part. This is an example of the Lewis dot symbol for the some elements in the period 2 and 3. So you can see that they are the red dot represent for the valence electron of the elements, and the symbol element represent for the nucleus and inner electron of the elements. So for the example, lithium are in group 1. It has one valence electron. So here it shows the Lewis dot symbol for the lithium. It has one dot. So for the beryllium, because it is in group 2, it has two valence electron. So there are two dots in the Lewis dot symbol. And the rest, you can see here, for the example, I take the group 17. So there are 7 valence electrons. So you can see that there are 7 dots around the fluorine atom. So how to write the Lewis dot symbol? For the example, I'm using nitrogens. Nitrogen, we know that it is in group 15. It shows that nitrogen has 5 valence electron. So you consider the nitrogen, the symbol of the nitrogen represent for the nucleus and inner electron, and we assume there are 4 sides for the nitrogen symbol. So you have to fill each side with the one dot. For the example, I fill the first side above with the one dot, and the second valence electron, the second dot at the next side. So at third electrons at the next side until it complete 4 side for the 4 electron, and the last electron pairing it at the first one, first side. So at one side maximum is 2 dots or 2 valence electron. So actually the box I put here just to show you how it has 4 sides. So you know you don't need to write the box actually. So to write this Lewis dot symbol for the nitrogen, you also can write like this one, or this one, or this one. So there are 4 ways to write the Lewis dot symbol for the nitrogens. Next, let's see for the example 1. I give you 5 elements. So for the example here, potassium is in group 1, and silicon is in group 14. So iodine group 17, and barium group 2, argon group 18. So potassium, it has 1 valence electrons, silicon has 4 valence electron, iodine 7, barium 2, and argon 8. So to draw the Lewis dot symbol for this element, for the example, potassium, the symbol of the potassium, because it has 1 valence electron, so there are 1 dot. You can put this dot, okay, at any side, okay. For me, okay, I put at the left side. You also can put at the right side, above or below. And the next one, silicon. Okay, it has 4 valence electron. So there are 4 sides of the silicon, so you can complete the dots at each side. Okay. The next one, iodine. Okay, let's say I starting at the top, 1. Okay, you have to fill each side 1 electron first. 2, 3, 4. And the next one, you pairing up 5, 6, and 7. So this is how the Lewis dot symbol for the group 17 iodine. Okay, and remember, okay, for this side, okay, you should draw the Lewis dot in this way. Okay, so not this way. So this is wrong. Okay, next, barium. Barium, it has 2 electrons. So I put here 1, another one here. And the argon, it has 8 electrons. Same as the iodine. I'm starting with the one side. For the example, I'm starting here 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So this is a Lewis dot symbol for the 5 elements. Okay, which is when you are given the elements. Okay, you should know the proton number, then you will know the valence electron, then from there you can draw the Lewis dot symbol. Octet rule is used, okay, in the bond when it's formed when the atoms lose, gain, or share electron to attain a field outer level of the 8 or 2 electrons. Octet is similar to the octagon. Octagon we refer to the 8 surface, okay, for the cube. So this one, okay, for the octet rule, it also considered the one with the 2 electrons. Okay, these 2 electrons, it also known as the duplex. Duplex. Okay, so okay, let's see how to achieve the octet configurations or obey the octet rule. The first one, achieving the octet by transferring of the electrons. Okay, transferring electrons, okay, it only occur for the formations of the ionic bond, which is, okay, the electron from the metal is transferred to the non-metal atoms. Let's see for the example here, I'm using sodium. It has 1 valence electrons. Okay, from the electronic configurations, it has 1 valence electron in orbital 3s. So to achieve the octet configuration 1s2, 2s2, 2p6, it need to transfer the electron in orbital 3s to orbital 2p of the fluorine, because fluorine, okay, it only has 7 valence electron and it needs another 1 electron to achieve the octet configurations, okay, which is it will accept 1 electron from the sodium and it will fill in the orbital 2p, then it will become 2p6. So it will achieve the octet configurations. When the sodium transfer its electron, 1 electron, it will become positive ions. Okay, with the electronic configuration for the positive ion is 1s2, 2s2, 2p6. While for the fluorine, when it accepts 1 electron from the sodium, okay, it will form F- an ion with the electronic configuration 1s2, 2s2, 2p6. So these two ions, okay, already achieve the octet configuration and obey the octet rule, okay, which is sodium. To obey the octet rule, it will lose electron, while fluorine, to obey the octet rule, it will gain electron. Next, okay, achieving octet also can be formed or achieved, okay, by sharing of electrons. For the example, between non-metal and non-metal atoms, okay, which is for the example I'm using fluorine. So we know that, okay, each fluorine atom has 7 electrons, and you can see that there are 1 electron is not pairing here, okay, and same for this atom. So to achieve the octet configurations, okay, these two atoms, okay, it will share the single electron to form molecule. Okay, so this is a molecule of the F2. Then you can see that between these two atoms, okay, it's sharing 2 electrons equivalent to 1 single covalent bond. So total electrons in each atom in the molecule for this fluorine, okay, 8 electrons, including the electron that share with another F atom. So there are 2 ways, okay, to achieve the octet configurations: by transferring of the electrons and sharing of electrons. Formations bond by using the Lewis dot symbol. There are 3 types of the bond. Ionic bond, also known as the electrovalent bond. It is an attractive electrostatic forces between positive and negative ion. Covalent bond, we refer to the chemical bond that involve the sharing of electron pairs between non-metal atoms. And the last one, dative covalent bond, also known as the coordinate bond, okay, which is both of the electrons come from the same atom. For the example, okay, here, atom A, okay, it has more electron, while B, it is lack of electron. So A, it will using one of the lone pair equivalent to the 2 electrons, okay, with the B, by forming bond between A and B. So the bond actually is the dative covalent bond, and bond is formed because it is come from the one atom, okay, which is it share both of the electrons with the B. So that is the difference between the dative covalent bond and covalent bond. Okay, covalent bond, each atom it will share the electron, but dative covalent bond, only one atom will share the electron. So let's see how the ionic bond is formed. For the example, okay, the formations of the sodium oxide. So by using the Lewis dot symbol, okay, from the molecular formula, you can see that there are 2 sodium and 1 oxygen, because oxygen, ion of the oxygen is O2 minus, sodium Na plus. So it needs 2 Na, okay, to balance the charge. Okay, each of the sodium atom, it only can transfer 1 electron. Okay, so that's why it needs 2 sodium atom. So by using the Lewis dot symbol, of course you need to show, okay, the valence electron by using the Lewis dot. For the example, sodium, okay, it has 1 dot here. Then what happened? Okay, for the oxygen, you can see that there are 6 dots, okay, and you can see there are 2 electrons, single electrons, okay. Then what happened? Each of the sodium atom will loses an electron, forming an Na plus ion. At the same time, okay, oxygen atom, it will gain 2 electron, forming O2 minus ion. So you have to show by using arrow when you transfer the electron, and the product is ion, okay. And how to write the ions? Okay, because you are using 2 and A, so you have to put 2 here, and using the square bracket, and outside the elements, okay, is the charge. And then for the oxygen, okay, you have to use the square bracket, okay, and you can see that because it gains 2 electrons, so there are 8 dots around the oxygen, and outside the box, the square bracket is the charge 2 minus. So the electrostatic attractions between the Na plus ion and O2 minus ion forming ionic bond. So this is how you have to describe the ionic bond, okay, by using the Lewis dot symbol. Let's see for the covalent bond. Okay, how the covalent bond is formed by using the Lewis dot symbol. Here I'm using the for example, okay, which is I'm using the hydrogen gas, oxygen gas, nitrogen gas, and some of the polyatomic ions. Okay, for the hydrogen gas, hydrogen atom, we know that it has 1 valence electron. So the Lewis dot symbol for the hydrogen, it has 1 dot. And when it combined with another hydrogen atom, then okay, this is a Lewis dot symbol for the hydrogen gas, okay, which is it share the each of the electrons, okay. Then in between of the hydrogen atom there are 2 electrons, but you also can write in this way, okay, you convert the dot into covalent bond. Okay, so this is how the to show the Lewis dot symbol, okay, for the covalent bond. The next example, oxygen. So here you can see that the oxygen has 2 single electron. So when it combine, okay, it share, okay, the single electron share. So each oxygen atom, it will share each of the single electron, and there are 4 electron in between of the oxygen atom. Okay, so we know that for the one covalent bond equivalents to 2 electrons. So if there are 4 electrons, means that there are 2 covalent bonds. You also can write the Lewis dot symbol for the oxygen molecule that like this one, which is you convert the Lewis dot symbol into covalent bond. And the last one, nitrogen. Okay, you can see there are 3 single electrons. Okay, when it combine, so it will be 6 electrons share between these 2 nitrogen atom. And you also can convert the 3 lone pairs or 6 electrons into covalent bond. So there are 3 covalent bond between the nitrogen atom or triple bond for the nitrogen molecule. So this is how you show the Lewis dot symbol, okay, for the formations of the covalent bond in hydrogen gas, oxygen gas, and nitrogen gas. So the difference is with the ionic bond, okay, you don't have to use arrow to show it share the electron for the covalent bond. But for the ionic bond, okay, you need to show arrow, okay, which is electron is transferred from the metal to non-metal. Okay, next, for the polyatomic ions, poly means more than one type of the elements. For the example, NH4+, it has nitrogen and hydrogen. Same for the carbonic ion, it has carbon and oxygen. And also nitric ion, it has nitrogen and oxygen. So this is an example of the covalent bond, okay, in the polyatomic ions, okay, between nitrogen and hydrogen, carbon and oxygen, nitrogen and oxygen. So if you check, okay, the octet configurations or octet rule, each atom has 8 electrons around its exceptions to the hydrogens, okay, it is not octet but it is duplet. So it only has 2 electrons. We refer to this bonding, okay, it shares with the nitrogen. So remember, okay, hydrogen only has 1 electron, and the 1 electron is shared with the another atom by forming bond. Okay, and the last part, let's see how the dative covalent bond is formed in the formations of the NH4+. Okay, so this is how the dative covalent bond is formed, which is, okay, for the ammonia, okay, it has one lone pair on the nitrogen, and when it combine with the H plus, ammonia, it will use the lone pair to form bond with the H. Okay, so as I told you, one covalent bond equivalent to 2 electrons. So nitrogen, okay, has 2 electrons, so it can form bonding. It can use it as to form bond with the H. So to show the dative covalent bond, you have to use the arrow, which is from the nitrogen to the hydrogen. Okay, so this is the dative covalent bond. Okay, let's see for the Al2Cl6 dimer. This is another example, okay, formations of the dative covalent bond between the two AlCl3 molecule, okay, which is it will form two dative bond. Okay, so how this bond is formed? When this chlorine of the AlCl3, it will use one of the lone pair to form bond with the Al. So it will form dative covalent bond. Okay, for this one, how this dative covalent bond form? When this chlorine used one of its lone pair to form bond with the aluminium. So it will form dative covalent bond here. So you can see that there are two dative bonds in Al2Cl6 dimer. So this one we call it as a dimer. Okay, so please make sure that don't use arrow to show how the dative bond form, okay, in the reactant parts. Okay, but for the product parts, okay, to show the dative bond, you have to use arrow, which is the arrow from the one that share the electron. For the example, this chlorine and this chlorine. Okay, let's see the last example. Okay, this is how the dative covalent bond between ammonia and BF3. So you can see that nitrogen has one lone pair and it can share the lone pair with the boron. So this is the dative covalent bond formed, okay, when the nitrogen share its lone pair with the boron. So for the structure of the ammonia and BF3, actually this one you can learn, okay, in the draw Lewis structure. So don't worry if the question give you the molecular formula. Okay, so after this, okay, when you learn about how to draw the Lewis structure, so you can do these questions. Okay, so this one actually just to show how the dative covalent bond form, okay, for this part. All right, okay, that's all. Thank you.